Is everybody able to see the full screen from one corner to other corner? Wonderful. Ariyahi, Vishali, Nanya, everybody? Shikhar, I could see. Okay. Shikhar and Ansika told me by nodding their head, yes, don't ask me this question again. Okay, so today's class is going to be a little loaded. When I say loaded, what it means is whatever we have learned before, that will be used very extensively in the class today. Okay? Before I start, is it okay for me to assume that you guys are very comfortable drawing a graph from an equation or drawing a line from an equation? Yes, Vishali.
Sorry, I lost my friend.
That's okay. Let me penalize you for the accident. Keep your video on with that. Okay. Alright. So what I'm saying is, before I get started, I wanted to know how comfortable are you guys drawing a line or a curve based on any equation that is given to you. If you have a linear equation, you can plot a straight line on a coordinate plane. You know how to do it. Say yes or no, please. Some clue. Okay? Alright. If I give you guys any quadratic equation like this, x squared plus 4x plus 7 equal to y, would you be able to draw this or give it a try to draw it on a coordinate plane? I'm just asking, just say yes or no. If it sounds new, complicated. Remember this, okay? Any equation, let me be very clear about what I'm saying. Any equation that you have, if you have to plot in a graph paper, there is no different science or math to it. It is as simple as this is a contract between the variables. Y says my value is square of x plus 4 times of x plus 7 to it. And you can literally create a table, put different values of x and find out the corresponding value of y. You can put x equal to 0, x equal to 5, x equal to 9, whatever you feel like. So what I'm saying is, any equation that you have, if I ever ask you to plot it on a coordinate plane, you will not go by the power of the equation, whether it's a quadratic equation, linear equation, any polynomial for that matter, you will not worry about it. Simple rule of thumb is simple rule of thumb is, any equation that you have, you will put the value of one variable and find out the corresponding value of the other variable. And once you have all the values, let's say 2, 9, 1, 7, 5, 6, I'm just making it up. Whatever values you have, you will locate those points and join them. If it makes it like a parabola, then it will be a parabola. If the points are such that when you connect them, it draws a straight line, let it be a straight line. Let's not overwhelm ourselves by thinking too much about it. For me, for you all, simple rule of thumb is, if I have an equation, that's a contract between the variables. One value I will put for this guy, I'll get corresponding value for the other guy. Keep doing that exercise. Whatever comes, 5, 6, 7 points I'll pick. Join those points on a coordinate plane and see what it draws. Yeah? Is that okay? So now, look, Sangeeta, Datta, Vasundhara, I don't know what happened to Ariyahi. Ariyahi's video was working perfectly fine, all of a sudden it disappeared. Everybody keep your videos on.
It says for me like something's blocking my camera, but I don't have anything on top of my camera, and I have it on.
Okay. So look at, there is a place, I'll show you. This is what happens.
Yeah, I know what you're talking about, but I tried to do that.
Don't worry about it, okay? I was just trying to make sure that everybody is paying 100%. So Sangeeta, Datta, Vasundhara, you guys can keep your videos on. So far, I have not taught anything I was just checking with you guys that if you have any equation and if I ask you to plot that equation on a coordinate plane, your strategy and approach would be very simple and straightforward. You put one value for one variable, see what is the corresponding value for the other variable. Keep doing the exercise with 5, 6, 7 points. Join those points and see what it makes. Yeah? So I'm not going to talk about drawing or graphing any equation for that matter. What we are trying to do. See, you guys have no idea how happy I get when I see your faces, okay? So that is what we call, that is a bonus for me. When I see my kids, I feel super happy about it. Okay? Alright. So today we are not going to talk about, see, now my kids are responding to my ask. Wonderful. Good to see you all. Now, I'm not going to draw any graph using any quadratic equation or a linear equation or any polynomial for that matter. Today we are going to deal with graphing a sine function or a cos function in a coordinate plane. Tell me honestly, who all has got any exposure to graphing a sine function, or sine curve, or cos curve, or tangent curve? Has anybody come across this before? Shikhar, Ansika, Vasundhara, Visali, Nanya, Sanita, anybody? No? So if I say that I'll give you guys $500, graph this on a coordinate plane, do you think that's looking like a winnable deal? No? Okay. Don't say yes. I'll be losing a lot of money. I'm just kidding. Coming back to a serious discussion. So today we will talk about how do we graph sine or cosine functions on a coordinate plane. Okay? Yes? No? Okay. Now this is going to be very intense because it is going to exploit our knowledge of trig functions, trig ratios that we have learned so far. And what I will do is, before I get started here, I will remind you of a table that I have shown you guys multiple times, and excuse me if I am claiming that I have shown and but I have not. If you guys vaguely remember, these are the most commonly used angles when we deal with trigonometry. Okay? So 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. I am just putting down the values here so that we can refer to it. 0, 1 by 2, 1 by root 2, root 3 by 2, and 1. 1, root 3 by 2, 1 by root 2, 1 by 2, and 0. And tangent is sine over cos, so 0 over 1 is 0. 1 by 2 over root 3 by 2 becomes 1 by root 3. 1 by root 2 by 1 by root 2 is 1. Root 3 by 2 divided by 1 by 2 is root 3. And this is undefined or infinity. So this is a table that I keep on going back to, okay? That's why I have plotted it here. And they are the most commonly used angles that we deal with when it comes to trigonometry. Do you guys remember that I have ever shown you guys this table, or we have tried deriving the value of these angles or these trig ratios for these angles? Samrita, do you remember that? This Sundara? Yeah? See, this is the advantage of keeping a video on. You don't have to say anything. You will just nod your face and I will know. Okay? Alright. Disali okay, beta? Disali, Sikhar, everybody? Okay. So you guys have seen this table and we have tried finding or deriving the value for these angles. I'm not doing it again. Though it is easy for me, but I'm not doing it. Just to be cautious about the time. Okay? And we'll keep coming back to this. Now there is one more concept that we briefly touched upon, that is degree to radian conversion. We also talked about that in the previous class. one of the previous class. 180 degree, if I am measuring in degree, if I want to convert, read that in radian, 180 degree is equivalent to pi radian. Yeah? Everybody? Okay. So, if I want to interpret these angles in radians, 0 degree will be 0 radian. 0 radian. If I want, so this is in degree and this is in radian. 0 degree is equal to 0 radian also. 30 degree is pi over 6 radian. 30 is 1/6 of 180 degree. So that is pi over 6. If I want to read 30 degree in radian, that will be pi over 6. If I want to read 45 degree in radian, that will be pi over 4. If I want to read 60 degree in radian, that will be pi over 3. And 90 degree will be pi over 2. Does that sound okay so far? To everybody? Datta, Nanya, Aryahi, Samrita, Ansika, everybody? Fikar? So far, nothing done. I am just helping you guys recall what we have done in the past, and we are just revisiting those things with the comparison between degree and radian. Now the actual circus starts. The question was, or the plan was, how do we plot sine of x? And here when we try plotting the sine function or cos function, we try using radians. Okay. So if I am trying to plot sine of x in a coordinate plane, this is how my coordinate plane will look like. Here along the x-axis I will have degree angles in, along the horizontal axis this will be angle in radian, and along the y-axis is my y, which is equal to sine of that angle. So whichever angle you pick, find out the corresponding value of y, and that becomes your coordinate plane. So again, horizontal axis is your angle in radian, and vertical axis is your the value of sine of that function. Yeah. So far okay, nothing complicated. And see, this is what we are trying to do, y equal to sine of x. So what we want to do is, my x is nothing but the angle in radian. So let's create a table here. Just because I have promised you guys always that I don't teach anything complicated, so I'll stick to that promise. And that is, this is the equation, this is the table that I'm trying to create. Let's find out few values for the angle 0 degree, pi by 4, pi by 2, pi, let's say 3 pi by 2, and and 2 pi. Why? Because I'm just trying to make sure that I make a complete circle. Now, when you look at these angles, this, if you want to think of this in degree, I'm just for reference, okay? 0 degree is 0 degree, 0 radian is 0 degree, pi by 4 is 45 degree, pi by 2 is 90 degree, pi is 180 degree, 3 pi by 2 is 270 degree, and 2 pi is 360 degree. I have created this column only for reference, okay? Is anybody stressed out so far? Nobody? That's okay. Ansika, are you getting stressed out, beta? You have turned off your video, that's why I'm wondering. Ansika is thinking, oh man, this guy is getting complicated now. No, so this is not complicated. Just to keep the jokes aside. Here, we are trying to plot the sine function on a coordinate plane where my x-axis is nothing but the angle in radian and y-axis is the value of sine of that degree. So here what we are trying to do is we are trying to put the different values of the angle for which we will find out the corresponding value of sine of that angle and then we will try plotting it. Let's say this is okay. I will decide on what my unit would be. Just because I have put the angles here, let's say this is 0 degree angle, this is pi over 4, this is pi over 2, this is pi, and this is 3 pi by 2, and this is 2 pi. Now let's try filling in these values. Sine 0, y is nothing but sine of the angle. Sine 0 degree is 0. No questions. Sine 45 degree or pi by 4. If you remember, wonderful. If you don't, you have the table for your reference. Sine pi by 4 is 1 by root 2. 1 by root 2. Pi by 2 or 90 degree. Sine 90 degree is 1. I am putting the value here. Sine pi 180 degree. That is not there in this table. Now we need to recollect what we have learned with respect to the unit circle, and you will see the application of unit circle here, or application of unit circle concepts here. So let me draw this unit circle here, and we will use this for reference. When I am talking about sine of 180 degree, meaning I am making half of the circle and coming to this point. Sine of any angle as per the unit circle theorem is the y coordinate value. As you would remember, any point's coordinates are cos of the angle, comma sine of the angle. When you come to this point, you are talking about sine pi or 180 degree. And here the y coordinate value is nothing but 0. So sine 180 is actually 0. Sine 3 pi over 2 or 270 degree. When you talk about 270 degree, you are making half the circle, which is 180 plus 90 more. When you come to this point, this is your sine of 270 degree as y coordinate and cos of 270 degree as an x coordinate. I am not really concerned about the cos of 270, I am only concerned about the sine of 270. At this point, as per the unit circle, I am looking at value of 1 with a negative to it, because my y coordinate value is negative here. Is it making sense to everybody? Sure? Everybody, Shikhar, Aryani, Dishani, Vasundhara, Datta, Samhita, Ansika. Okay. So here at this point, when I am talking about 270 degree of sine, I am coming to this point and where I see my y coordinate value is 1 because it's a unit circle with a negative to it. So my sine 270 degree is minus 1. Now if I am talking about sine 360 degree, what is happening is I am making a complete circle and landing in a place where I was in the beginning, where sine or the y coordinate of this point is again 0. So, if you look at what I have done so far, we talked about the need for us to draw the sine function on a coordinate plane. That's what we are trying to do. Okay, that's a simple one-liner ask we have. And to be able to do that, I mean, this is my equation which I am trying to plot. For every angle of sine, I am trying to find out for every angle I am trying to find out the sine of that and try to plot that in a coordinate plane. So my x-axis or the horizontal axis is nothing but representing the angle in radian, and y-axis will be the sine value. Now here, what we did was we took reference of our most commonly used triangle to find out the value of sine up to 90 degree, and as soon as we came across the constant that I cannot use this table for the sine values, as soon as we found the need for going beyond 90 degree, we leaned on the unit circle concepts to find out the value of these angles. And now we have the table with x and y value, and we are just wanting to plot it. So there was an equation, we found the value of one variable, corresponding value of the other variable, created this table by hook or by crook, and now we are trying to plot it here. Now look at this. When x is 0, y is 0, meaning when the angle is 0, my sine x value, which is y, is also 0. So we are starting from this point. When x or the angle became pi over 4 or 45 degree, the value is 1 over root 2. Root 2 is around 1.414, if I am not wrong. So this will be somewhere around 0.6 or 0.7. 14, 7 and 98. Yeah, 0.7 approximately. So 1 over 1.414 is approximately 0.7. So I'll just do some rounding. So let's say this is 0.5 and this is 1. Here it is minus 0.5 and here it is minus 1. And why I'm using these units, because you can see clearly when you are going from 0 to 360 degree, your value of sine x starts from 0, goes to 0.7, goes to 1, again goes back to 0, to minus 1, and then goes back to 0. So your value of sine x, if you look at it, value of sine from 0 till 360, y value is oscillating between 1 and minus 1. Maximum value is 1, minimum is minus 1. When you add more to it, it will keep, it's like a pendulum. Here you have 1, here you have minus 1. It will keep on oscillating between these two. More you go revolving this around the circle, this is how your pendulum or the value of this will oscillate. Does it make sense? So in summary, what I am saying is your sine value of any angle ranges between minus 1 and 1. That's what we saw from 0 to 360. Yeah? Agreeable or not? So that is why I picked these units, so that we are able to plot it. Now let's look at it. This was my first point, 0, 0. Second point is when angle is pi over 4, it's going to approximately 0.7. I'm just rounding something, okay? Here. When it became pi or 90 degree, pi over 2, it came here. When it became 180 degree or pi, it came here. So if I just try joining it with a free hand, it's coming like this. And then what you're seeing is when 3 pi over 2, it became minus 1. So what you're seeing right now is a sine curve. What I've done is from 0 to 2 pi I have tried plotting, and this is how a sine curve looks like a wave. Okay? And you would have seen this, you would have heard about it 100 times for sure. So a shape like this is called sine curve. And the behavior of this is, if you extend this, if you have more time like I have, you will see that this sine curve will keep on repeating like this. Not only in the positive direction, if you talk about the angles which are negative, you will see this. So this is a sine curve. So what it means is, your sine curve will always be like this. And we just applied 3 concepts. One is our basic understanding of coordinate plane, our understanding of the basic trig ratios, and if we have to go beyond 90 degree, we have to borrow concepts from unit circle theorem. All these three things together helped us draw this sine curve. Did that make sense to everybody, or I was just able to convince myself? Make sense? Did it make sense? Dishali, Shikhar, Aryagi, Samhita, everybody, Ananya, Datta. So, see, it boils down to one really basic fact that I keep bragging about. I always say that I don't teach anything complicated because I don't know that. I only know basics. If somebody says, this is an equation, plot it. For me, this is one variable, this is another variable. I will find out the value, I plug in the value of one variable and find out what is the corresponding value of the other variable. Create few combinations, create this table that you guys would have learned at least 3 years ago, right? That's when you got introduced to coordinate plane. That you have an equation, plug in the value of x, find the corresponding value of y, plot it. I did the same thing, I did not do anything different. Yeah? So yes, you guys are forced to say yes. No, I'm just not forcing anybody. I'm just saying that this is my understanding. I'm assuming that this is in line with how you guys are looking at it. Yeah. Now, if I pause here and say that I want to plot cosine curve also, meaning I want to plot a curve like we plotted y equal to sine of x. I want to plot y equal to cosine of x. Can somebody tell me how would I start? Would I do anything different, or would I do somewhat similar to what we did just now? Do not be shy. Say something. Is it okay for me to use the same approach for plotting cosine of x also? Yes, and it doesn't, see, for you guys to acknowledge or talk to me, it doesn't require any amount of bravery, okay? Okay, so please don't be shy, say something that will give me that fuel to fire. Okay? Now same thing, I will do the same thing. We have the table ready for us, just that we'll have to, what I will do is, I will just put a small summary of the table that I put above. I'll only put the cos value here, okay? For these angles, 0, 30, 45, 60 and 90. The reason why I'm doing it, because if I keep scrolling it up, it takes a lot of time. I'm just trying to save time for you guys, okay? Now, again, 0 degree in radian is 0 radian. This is degree, this is radian. And see, while it might sound like I'm trying to do some boring stuff, but actually we are together trying to make some observation and see what is the difference between sine curve and cosine curve. And after I'm done, you will have a very clear understanding of what is the difference between sine and cosine curve. Tomorrow it might so happen that you are in a test and you will get a question saying, there are 4 graphs given to you, say, okay, figure out which one is representing this particular sine curve or cosine curve. If you have this picture in your mind, you see, if you have 4 options and only one of that looks like this sinusoidal curve, this is called sinusoidal curve also, okay? So, if anything is looking like this and you see that, okay, after every 2 pi, this whole cycle repeats. It ranges from +1 to -1. You can blindly pick up this as an option. Yeah. So now let's come to cosine curve. Okay. So let me put this table real quick. 0 degree, 0 degree, 30 degrees pi over 6, 45 degrees pi over 4, 60 degrees pi over 3, 90 degrees pi over 2. Let's look at cosine of 0 is 1, this is root 3 over 2, this is 1 over root 2, 1 by 2, 0. So we have this table for reference. Same thing I will do is, I will quickly draw this unit circle also, because we know that we need this. So this is my unit circle. It will only be a quick reference guide for us, okay? It will just tell me what my values are going to be. So we know that we have to create a table of values, and then we will try plotting it. So let's create a table first. This is my x, this is y, and equals cos of x, and this x is in radian. For reference, I am putting degree here. Okay. I will get you guys bored and tired of it by giving multiple examples, so that after some time it will become a normal course. So let's say I'm talking about 0 degree, that is 0 radian. I'm talking about 30 degree, which is pi over 6 radian. I'm talking about 45 degree, which is pi over 4 radian. Talking about 90 degree, pi over 2 radian. 180 degree, pi radian. 270 degree, c by 2 pi radian, and 360 degree. I'm just trying to make a complete loop. 360 degree, 2 pi radian. Let's plug in the value for this. 0 degree is 1. 30 degree or pi by 6 is root 3 by 2. 45 degree is pi by 4, which is 1 by root 2. Or we have figured out it's almost like 0.7. This is root 3 is 1.732 if I'm not wrong. Divided by 2 will give you 0.88 approximately. Or 87 maybe. 0.87. Okay. 90 degree, cos 90 degree or pi by 2 radian is 0. 180 degree, now comes the actual thing. When I'm talking about cos 180 degree, I am making half the circle, and cos is nothing but the x coordinate value, which will be -1 in this case. So this became -1. When I go to 270 degree, I am completing this half circle and then one more quadrant, and I am landing at this point. At this point, what is my x coordinate value? 0. Y coordinate value is -1, which is sine of that angle. I am only concerned about the cos of the angle. So at this point, after making 270 degree, my cos becomes, or my x coordinate becomes 0. So I will put 270 as 0. And 360 degree again, when I make a complete circle, land at this point, my x coordinate or cos 360 degree is nothing but 1. So this is what you are seeing here. Are you guys okay with the way I have plotted the table? I mean, put the value in the table. Everybody comfortable? Nothing new, nothing complicated. Ansika, Hariyahi, Ananya, Datta. Everybody okay? Okay. Now we have all the values that we need. You forget about the degree now, because this was only for our reference. So let's knock it off. This is 3 by 2 pi. Same step we will do one more time. And good news is the cos value is also ranging from 1 to -1. So maximum is 1, minimum is -1, and the whole cycle repeats. So this is 0. Let's say this is 30 degree, pi by 6, pi by 4, pi by 2. This is pi, 3 pi by 2, 2 pi. Now you will see something interesting. Again, since it's ranging from 1 to -1, here I will put 0.5 and here I will put 1. Here it is -0.5, here it is -1. Let's try locating these points on this plane. 0 and 1. When x is 0, meaning my angle is 0 radian or 0 degree, my y coordinate, or this is y as in cos of x is equal to 1. When this is pi over 6, this is root 3 by 2, which is 0.87. It came a little bit down here. When it's pi over 4, it became 0.7. It came down a little bit further. And again, I know I'm not doing a great job with drawing, but bear with me. When pi over 2 is, when the angle is pi by 2, this became 0. When the angle is pi over 2, the cos value became 0. And then when pi was, when the angle was pi, here it became minus 1. And then 3 pi over 2 became 0 again. And for 2 pi, it became 1. Here somewhere. So if I do a freehand drawing and I join these points, this is my cosine plot or graph of cosine function. Now you would want to make an observation here. See, it started from 0 at 2 pi. Yeah. At 2 pi, it landed in the same place. Here also, if you see, started at 0, at 2 pi, it landed in the same place. Okay? So what is happening is, you can think of it like if you shift this sine curve by 90 degree, meaning this point if you move by 90 degree or pi by 2 radian, you will see the same thing that you are seeing here. So sine curve and the cosine curve are nothing different. Only difference means sine curve starts from 0 and makes this and comes to this point. The cosine curve starts, it shifts the whole thing by 90 degrees or pi radians. So if you move your sine curve by pi radian, so shift it by this much space, you will see that it becomes your, so not this much, by this much, pi by 2, if you shift by this much, you will get your cosine curve. So sine curve and cosine curve are no different. It's all the same. Only thing as a takeaway or a thing to remember in a more intuitive way is, if you are starting from 0, you're talking about sine curve. If you are starting from pi, when this point starts from here, this is sine curve. When this starts from pi by 2, you're looking at the cosine curve. Both are the same. This is the only difference that you might have observed. Let me pause here and see if whatever I have told so far, did that make sense to you guys? Or let me put it this way. If you come across this term, how do you plot a sine curve? Would that bother you at all? No, right? Is no a right statement? Ansika, Shikhar, Disali, Sundara. Let's look at this whole journey. See again, sine curve, cosine curve, tangent curve, these are the most scientific form of trigonometry that we started learning recently. Okay? So you will see that these are used more extensively. I mean, if you remember having seen that, what is that called? When you go for some, I mean, you guys don't have to do it, but mostly elderly people, when they go for it, what is that called? It's echocardiogram, right? Echocardiogram. You would have seen a white paper, a report from the doctor, it will be like a graph paper. You will see these things being plotted. Okay, it measures your heart rate and plots a graph like this, from which the doctors read and see the health of your heart. Okay, it's called echocardiogram, if I'm not completely wrong with my understanding of the term. Okay, this is not my field, so obviously I'm as no voice as you guys can think of. But the point is, we are inching towards the scientific side of trigonometry, where we apply that in real life. I mean, sine 30 degrees 1 by 2, that's okay, good to know. But where is the application? They are the ones where you start applying it. You will see a lot of concepts get used in all scientific research, medical science and whatnot. So let me not try selling the concepts, but what I'm trying to say here is, whatever we have learned, we are seeing the application of it to relate to it, and these graphs are used extensively for scientific purposes. Depending on which field you guys go to, you'll see the application of it. But the summary that I'm trying to put here is, drawing a sine curve or drawing a cosine curve is not a big deal, as long as we stick to the basics. Any curve that we draw from an equation, or any graph that we plot from the equation, you have two variables. One variable goes as an input, other one is your output. Here your input is angle, output is your value of the sine of that, or trig ratios, sine of the respective angle. Based on what we know from these commonly used angles and our understanding of the unit circle theorem, we found out different values of sine of different angles, and we tried plotting that in a coordinate plane, where my horizontal axis is my angle and vertical axis is my value of the sine of the respective angle. And when we tried plotting it, it plotted the sine curve for me. When we had to do it for cosine, use the same approach, same concepts. Only difference we saw was sine starts from here, cosine starts from here. Yep. Is everybody okay? Now if I asked you guys that, can you tell me at what point the sine and cosine curve will intersect each other? Let's see. It's a what do you call it? It's a concept that you guys know. Okay? So first thing I would say is, believe in yourself that yes, you know it. Now think about some creative options to tell me at what point, let's say in the same graph, okay, in the same coordinate plane, I am trying to draw cosine curve which is going like this, and the sine curve which is going like this. So we certainly see that the sine and cosine curves are intersecting each other. My question to you is, what are the points or what are the angles at which the sine and cosine curve will intersect each other? Let's see how much you guys trust yourself. And you know it, trust me, when I explain this to you guys, you will acknowledge that yes, you know it. You knew it actually. Visali, Nanya, Nutta, Ansika. Yes, Ansika, tell me. 45 degree, okay? A 45 degree, and now I am trying to act smart. I will start talking in radian, okay? So if you say 45 degree, I will convert that to radian and say 5/4 radian. Okay, what else? I want 10 answers. Visali, what do you think? 45 degree is one answer given by one of your friends. I agree. What else?
I was thinking about 45 things here.
I'm saying there will be, I can cook up 20,000 answers for this question. or maybe more, depending on how jobless or how free I am. Let's see what Sika says.
There's a 90-degree angle.
Say one more time.
90 degrees is equal to pi over 2.
90 degrees pi over 2, yes. So remember this thing. Pi radian is equal to 180 degree, always. Now you can do your math. Yep. Yes, Asika, you have more ideas. 100? 225 degree, okay. Anybody else? Datta, Sanvita. So Ansika has put me on the spot, 225 degree. And I said I will put that in radian. So it's pi is 180 degree and plus 45 degree is pi over 4. So which is 5 pi over 4 radian. Okay. Let's see. Sanvita, what are you thinking? Tell me. I was asking, see, we saw that whenever we have sine curve, it starts from here. That's what we had drawn. When we have cosine curve, it starts from here. So we see that the sine curve and cosine curve intersect each other. I'm trying to find out what are the angles at which the sine and cosine curve intersect each other. Yes, so Srikar. So Sanita, you think about it. I got two answers from Ansika. One is 45 degree and 225 degree. Srikar, what is your answer? Huh? Okay. So here's the thing. Okay, here's the clue. Vasundhara missed the clue. She just dropped off. So let me show you guys what I was hinting at. I was telling that sine and cosine curve, they intersect each other at multiple places. It's intersecting here, again intersecting here. I'm pretty sure it will intersect again. Intersect again. I will not worry about this part. What I will do is I will relate that with my understanding of unit circle theorem. Where is my unit circle? Unit circle is here. Now, if I am trying to find out where my sine and cosine curve will intersect, simple thing is, wherever they intersect, that means at that point, the value of sine of that angle and value of cosine of that angle will match. Yeah? That is where they are intersecting, right? That's the only reason they are intersecting, correct? This is my sine curve, this is my cosine curve. If they are meeting here, that means at that point, the value of sine of that angle and cosine of that angle both are matching. That is why Ansika picked up the first easy one, saying 45 degree, because of two reasons. One is this table that I had shown you guys. Sine, cosine, tangent. I will not talk about other angles, I will only talk about 45 degree. Sine 45 is 1 by root 2, cos 45 is also 1 by root 2. So that was the first pick Ansika had. And she said that yes, I know at 45 degrees both are having same value, that's why they are intersecting. Yeah? Make sense? Now, let's go back to this unit circle. See, where your sine and cosine matches, when your x and y coordinate have same value, meaning when this angle is 45 degree. This point, your x coordinate and y coordinate both are positive and have the same value because it's a isosceles triangle with 90 degree here and both 45 degree. If you go to this side of it, your sine and cosine will not match because your sine will be positive and cosine will be negative. You will not talk about that. So when I go to other one, when it's again, it has to be 45 degree with the x-axis, okay? Meaning 45, here is 45, but when you come to this point, it's 45 plus 90, 135. But that one is not matching because your sine is different, is positive, and cosine is negative. Same magnitude but opposite direction, right? So you will not say they are the same. But when you come to the third quadrant, your cosine is negative and sine is also negative. So that is why 180 plus 45, 225, it will match and this cycle will repeat. Here again you will not think about it. So 45 and 225. So 45, 225. Again make one complete circle. 360 plus 45. That plus 360 plus 225. So 45 and 225. 225 was 5 pi over 4, right? So this combination will match. This is where they are matching. And you will keep on adding 360 degree to it. 360 degree, so these two match. Another 360 degree, you are landing in the same place, again will match. So you keep adding 360 degree. If you are being tasked to find out 50 values of the angles for which sine and cosine will match, and you know that there is an award of $200, do that exercise. You just adding 360 in the iteration of 360. So basically, you know that this one and this one matches in sine and magnitude both. So keep adding 360 to it. One more time 360, one more time 360, one more time 360, and you can keep going in loop depending on how many values you have to find. So Anshika gave me 2 clues. I'm saying that you can add multiples of 360 and you will have as many numbers you can think of. Yeah? Makes sense or not really? Srikar, Ananya, Datta, Sundara. Everybody okay? So we have just 6 more minutes. And I don't think I would be able to draw the tangent function on the coordinate plane in the 6 minutes, okay? That will be just too much of a rush. But let's try to understand. Let's try to think about it, okay? What do you guys think? You saw that when you're talking about sine curve, it starts from here, goes like this. After every 2 pi, it goes to the same point and then the cycle repeats. If you're talking about cosine curve, it starts from here, from the maximum point, and then after every 2 pi, the cycle repeats. So, same curve shifted by pi by 2 or 90 degree. How would a tangent curve look like? Would it be a continuous curve like sine and cosine, or it could be different? Let's see how you guys are thinking about it. I will give you guys a clue, okay? Somebody is saying something. I'm super happy. Yes, sir, go ahead.
I think it would look different and it would be like on both halves of the graph, like the top and bottom.
Okay. Let's see. It is another point of view. Shikhar, Datta, Dishali, Vasundhara, Nanya, Ansika. See, my question is simple. I'm saying that sine and cosine we saw it moving by 90 degree or pi over 2 radian. Now, if we have to envision or visualize how a tangent graph would look like, what is your guess based on certain thoughts? Okay, so let me give you guys some clue here. I will draw this in the next class, but I want to give you guys some clue here. And I keep going back to this table, okay? Because my plan is to make you guys get bored and tired of this table. Yes, Sikar.
Would it be like a curve, but it's the top and bottom part of the graph, so it looks like a straight line curve into the origin and then back down straight.
Actually, I mean, exactly, that's what I was trying to depict here. See, just look at this table. It will make a lot of sense to you guys. Tangent is nothing but sine over cos. Here it is 0. This is 1 by root 3. This is 1. This is root 3. This became undefined. This is the guy who creates maximum problems for us. After every 90 degree, you will come across a point where your sine over cos will become undefined. If you look at your unit circle, when you are here, life is going fine up to 90 degree, just before 90 degree. If you look at sine value is increasing when you are going to 90 degree. It's increasing. Cosine is decreasing. So y value is increasing, and as the angle increases, the x value is decreasing. When you come to this point, 90 degree, your x value became 0, cosine became 0, sine became maximum. So 1 over 0 is an undefined state. You cannot locate where this ratio is going. Look at this one. Let's say sine over cos is 10. This one is increasing, this one is decreasing. So it was going up. As soon as we went to 90, it took off. Similarly, you will see that when you go in negative direction, the same thing. So your tangent curve will look something like this. And again, if I am not making sense, let it not make sense. Okay, class is almost over. But what I am saying is, you will, in the sine curve, you saw continuity. Here, you are coming across these points. At those points, this is becoming undefined, and you will see that your curve just takes off. The curve's continuity breaks. So here you have one curve. Here you will have number of curves. And again, all that I am saying in air right now, I am just giving you a clue that at every 90 degree, your function becomes undefined, your value becomes infinity, and that is where you will see tangent curve looking like a stepchild in the family. Sine and cosine have a relationship. It just shifted a little bit. Tangent is actually tangent. Yep. So we'll see it, okay? And that is where we'll try relating to it. Net, see, now we are getting to a point where we are relating the concepts to visualize it. We have gone beyond a point where we are say, okay, how to find out sine 45 degree. Those are baby questions for us now. We are looking at the application side of it and see how it can be used. So again, I'm not trying to make you guys think that finding out sine 45, 60 is not relevant. It is relevant, but I'm saying we have gone a little bit further in the concept to see the application of it and to make us more comfortable with what we have learned. Alright? With that being said, I'll let you guys go. Enjoy the rest of the evening. I hope we learned something, we saw something, and there are some takeaways. Yep. Have fun. Watch the video of the class to catch up. Whatever you missed, you should go to the later. Alright? Have fun. Bye bye. Bye bye. Bye bye.